The question today is what holds atoms together? We are going to be talking about the structure of an atom, the subatomic particles within the atom, and the forces that hold atoms together. So to begin, all matter is composed of atoms. They're the basic building blocks of all life and all inorganic matter as well. So atoms can neither be created or destroyed, and they can't be divided either. However, in certain situations, like in nuclear reactions, this can happen. Every element on the periodic table is made up of unique atoms in which each atom has its own set of intrinsic properties or unique properties to that atom. As an example, the atoms of copper have unique properties, the atoms of hydrogen have unique properties. This image is really interesting because it is the first ever high-resolution image of a molecule breaking apart and reforming new chemical bonds. So you can see in the very top in the colored image, the molecules look very different. On the top left, it almost looks like a backwards L shape, and on the top right, in the B block, it looks just kind of like a blob. So if you change the resolution of the image and go down to the black and white, you can see on the left it almost looks like the shape of an M, and then there's three distinct spheres within that shape, and then on the right it almost looks more like a honeycomb structure, and it kind of just looks like a blob. Well, down below it's showing that you have this carbon and hydrogen structure, which is in a very specific M shape, and you can see that in the middle picture on the left. And what it does is it breaks apart and reforms into a completely different product, which has a completely different shape. So we've always known that chemicals react like this. This is just the first image that we have of that actually happening. The structure of an atom is broken down into a couple of distinct parts. In the very center of the atom you have the nucleus, and within the nucleus you have neutrons and protons, and then outside of the nucleus you have electrons. This model in the picture is called the Bohr model. It's not a very accurate model, but it's very easy to visualize and very easy to understand, so we're going to be using this model over and over again to describe and visualize what atoms look like, knowing that it's not perfectly accurate. There are better models, newer theories of atoms that have come out since this model that have kind of debunked this model of the atom, but we're still going to use it to help visualize atoms. An atom can be defined on the periodic table by its atomic number. So each different element on the periodic table, as an example, hydrogen is number 1. The reason why hydrogen is number 1 on the periodic table is because it has 1 proton. So elements are defined by the number of protons in the nucleus, and we call that the atomic number. Another example, which this model on the right is showing, you can see that there are 4 protons, the red circles in the nucleus. If something has 4 protons, it has to be beryllium. Beryllium is number 4 on the periodic table. Something interesting about an atom, if you think about atoms, we can't actually see individual atoms, but we know that the majority of an atom is made up of empty space. So if you visualize an atom as if it was a football stadium and you put a piece of sand, just one grain of sand at the very center of the football stadium, that grain of sand represents the nucleus. And within that nucleus, you have those subatomic particles, protons and neutrons. Outside of that nucleus, or that grain of sand, you have the rest of the atom, which is visualized by the rest of the football stadium, mostly made up of empty space. And then there are electrons floating around in what's called the electron cloud. But those electrons don't take up very much space. They're also very tiny. So this analogy is really helpful in understanding the relationship between the size of an atom to its nucleus and how small that nucleus actually is. So getting deeper into subatomic particles, this first model on the upper left shows an atom. And if you break an atom down, you can break it into its nucleus, which is at the very center, and the electrons, which are in the electron cloud outside of the nucleus. If you break down the nucleus even further, you can break it down into the protons and the neutrons, and then even further, you can break down protons and neutrons into what are called quarks. Quarks are really interesting particles that make up the subatomic particles. So subatomic particles are protons, neutrons, and electrons, and then quarks make up protons and neutrons. Quarks have kind of funny names. There are a couple of main types of quarks. There's an up quark, a down quark, a strange quark, charm, top, and bottom. The people who named these had pretty good senses of humor when they were doing that, and a couple of them are actually named after a science fiction book. So, if you get into the nucleus of an atom where the protons and neutrons are housed, protons and neutrons are subatomic particles that are made up of quarks. Well, more specifically, protons are made up of 2 up quarks and 1 down quark. So you can see in the image on the bottom right, you have 2 ups and 1 down. And this proton has those quarks within it that are held together by gluons, and you can think of gluon as glue that holds the quarks together. Well, the reason why I'm talking about this is so that you can get an understanding of why these subatomic particles are the way they are. So if you take 2 up quarks, each of those quarks has a charge. They each have a charge of 2/3. And that down quark has a charge of -1/3. When you add all those quark charges up together, it actually equals +1. Therefore, we say that protons have a positive charge. And it happens to be specifically a +1 charge because that is the addition of all the quarks within the proton. A neutron is slightly different in its quark structure. A neutron has 2 downs and 1 up. So if you have a neutron with 1 up quark, which is 2/3 charge, and 2 down quarks, which are both -1/3 charge, you add all those together and it equals 0. Therefore, we say that neutrons are neutral or have no charge. An electron exists in the electron cloud. Electrons are tiny, tiny, tiny particles. They're about 1/2000th the time smaller than a proton or neutron. And they are made up of what are called leptons. We're not going to worry too much about what a lepton actually is, but the reason why I'm talking about leptons is because electrons are not made of quarks. They are not made of quarks. They're made up of something totally different, which is called a lepton. So we're just going to call them electrons, and electrons have a -1 charge. Okay, so now that we know what's in the atom and where these subatomic particles exist within the atom, let's talk about what holds those atoms together. So we first have to talk about what's called an electrostatic force. An electrostatic force says that if you have like charges, aka a positive and a positive, or a negative and a negative, they're going to repel each other. The opposite of that is if you have 2 charges that are opposites of each other, like a positive and a negative, they're actually attracted to each other. This force is called an electrostatic force. So circling back to protons and electrons, if a proton has a +1 charge and an electron has a -1 charge, those are opposite charges which are attracted to each other. So the electrostatic force or electromagnetic force, we'll use those as synonyms, are what keeps the electrons in the electron cloud attracted to the nucleus of an atom where the protons are, because those electrons are attracted to the protons. So it kind of keeps the whole atom together. In addition, you have what's called a strong nuclear force. If you think about it, in the nucleus of an atom, you have protons and neutrons we know have no charge, so they don't really do anything. The protons, if you look at this model on the right, you can see that there's 7 positive charges. Well, we just reviewed the fact that like charges repel each other. How is it possible that there are 7 positive charges right next to each other in the nucleus? That doesn't make sense. You would think that those protons would want to be as far away from each other as they possibly can. Well, we know that the strong nuclear force is what prevents the nucleus from breaking up, and the reason why that happens is because those neutrons act as a buffer system. So those neutrons prevent the repulsion between the protons and prevent the neutrons from exiting the nucleus, thereby keeping the whole nuclear structure together. The nuclear force keeps the nucleus together, and the electromagnetic force keeps the entire atom together. When all of these things are aligned, we say that the atom is stable. When all of these things are unaligned, we say that it's unstable.